Hello my dears and good afternoon. My name is Mr. Harem and today we're going to start with a new unit of our science lessons. Previously we actually explained two of the main topics that are important for this topic and the upcoming ones. We talked about material change and we also explained forces and motion. From today onward, we're going to use the forces and the energies that we have along with the matters that we have explained previously in order to build electrical circuit. Let's see how we can do that. First of all, as this is the very first lesson of this unit, we're going to familiarize ourselves with what's a circuit, to know what a circuit is, what's a conductor, what's an insulator, which materials are good conductors, which materials are good insulators. Let's see what we have. What's a circuit? A circuit is where electricity can flow through a series of conductors that form a complete loop. So, we have electricity and we have conductors. Let's see what we mean by conductors. Materials can be tested by completing the circuit between the conductor and the bulb. For instance, we have a bulb over here, as you can see. That bulb is connected to wires, okay? Cables, wires. We also have a battery. We also have a switch over there. So, if the electricity, if the power, if the energy from the battery goes through the wire to the switch, then from the wire to the bulb, and the bulb turns on, it means the materials used to connect to light the bulb are conductors because they transfer energy, they transfer electricity. Okay, so if the bulb lights up brightly, okay, it means electricity is passing through the materials, through the wire, through the switch to the bulb. Okay, so what if the bulb doesn't turn on? If the bulb doesn't light up, the materials must not allow electricity to pass through it. Therefore, they are called by insulators. So, some materials allow electric charge to pass through them easily. These materials are called conductors. So, in here, we understand that the materials that let electric charge to go through them, to pass through them, are called by conductors. But the materials that don't let electric charge or electricity to go past them, to go through them, are called by insulators. As you can see in the examples in your right hand, we have a metal nail over here connected to the wire and then to the battery and then to the bulb. But still, the bulb lighted up, it's working. But if you see the second one below, you can see that a plastic spoon is used instead of the nail, which indicates that we have an insulator. How do you know that? Because the bulb is not lighting up, is not working. And just for your information, humans are very good conductors of electricity. So if you touch an electrical main or an electrical wire or anything that electricity has been going through it, you'll definitely get electricity shock, or maybe a human being can be killed because of electricity as well. So then we have mains electricity and batteries. So we can make comparison between batteries and mains electricity. Some electrical appliances use batteries as source of their electricity. So batteries can be used to transfer electricity, to transfer energy. In many cities and homes, so at our homes, we don't use batteries to make our appliances work, okay, to turn on our appliances. But what we use mains electricity. We use what? We use the plug. We use, let's say, any source that comes from mains electricity in order to make our home appliances to work. Although we still have some appliances at our homes that they should work using batteries because they could not endure, or they cannot endure the force or the energy that mains electricity will receive or can receive. Therefore, a question is rising in here. To know about British or any other country's mains electricity, what's the difference between the electrical energy you get from each of these? So what are the differences between them, or what's the main difference between them? Because we get electricity from mains electricity when we have it at home. We don't get it from batteries usually. But what are the differences between batteries and mains electricity that we have at our home? Can you turn on your appliances, your home appliances, with batteries? Let's see. I want an answer for that, please. Write it down on your notebook. So let's see how that electricity is transferred or gets to our houses. Cables are made of two or more wires fixed together side by side and are used to conduct electricity. So electricity comes to our houses from the power sources by using cables. Electricity from the mains are much more powerful than from batteries. So this can be an answer for the previous slide. When electricity is used to make something work, scientists say electricity powers it. So any appliances that you see in this picture from your left hand, these are all working by mains electricity. These are not working by batteries. Okay, you cannot turn on an iron using batteries. It's very hard. Even sometimes the electricity will not endure an iron, which actually is the very strongest ones. Therefore, cables are used, and they are all electricity, like powering them. Okay. Therefore, scientists call each one of these appliances as electricity powers them or it individually. As you can see, cables are made up of what? Of plastic and something else, a copper. Okay? So home appliances, I want you now to write down 3 appliances that use batteries in your home. And I also want you to write down 3 more appliances that they use mains electricity to work. Okay? Not batteries, mains electricities. So 3 for batteries, 3 for mains electricity. Electrical current. Let's see what electrical current means. Electricity flows through a circuit when everything is joined up correctly. We call this electricity the current. So when everything is joined up correctly in a circuit, in an electrical circuit, we call it as electrical current or current itself. The current flows from the power source which produces the electricity through the conductors and back to the power source. So we have a power source, let's say, and from the power source through cables that you can see in this picture, the electricity is transferred, is sent to our home, because we know that cables are conductors. Okay, so then it gets to our home from the power source. Okay, from what? From power source using conductors to our home, and it gets back to the power source through the conductors. It's like what? It's like a running track, as you can see in the picture in your right hand. Okay, and electrical current is also like the left picture, as you can see in your screen. So as you can see, we have a battery over here, which we call it as a power source, let's say. We also have the wires sending electricity or making an electrical current and sending it to our house. and the bulb turns on. So this is the bulb in our home. It's similar to what? To a running track. So it comes and goes back in this way. If there's a break in the circuit, you have a circuit and there's a break in it, the electricity will not flow. Your appliances will not work. As you can see in the two pictures you have in front of you, from the very first one, which is written on, which the current has been made and it's a closed circuit, which means it's closed and it's working, it's not an open circuit. You can see that the bulb is working because the wires are connected together and then to the battery. There's no problem. But the one in the right, we have a break in here. Because of what? Because the circuit is open, okay, and it's turned off. The bulb is turned off. There is a break in this, let's say, location. Therefore, the bulb is not going to work, okay? So previously we said that conductors or cables or wires are made of plastic and a copper, okay? So outside of it is plastic, inside of it is what? Is a copper. This was one of the checkpoint questions, which actually is from one of the previous years. So the outside of the wire is made of plastic. Explain it. Why it's made of plastic. I'm going to answer this today, but when we are at school, we're going to answer it together, which means I'm going to ask you to answer these questions for me. Okay, so the reason behind using plastic for the outside of wires or cables is because for human beings, when we touch it, or when the cables come to our houses, when birds are going to be on them, they don't experience an electrical shock, because we said that electricity can kill people, can kill human beings, can kill any living thing. Therefore, it's made of plastic so that it does not shock human beings or any other animal. The inside of the wire is made of copper. Explain why. The coppers are actually one of the most important conductive materials, which means they are conductors. They are sending electricity to our houses or to the place intended. Okay, so these are the reasons behind using plastic and copper in the wires for electricity, or to transfer electricity to our houses. Thank you very much for attending this lesson. Very well done. Have a very good day.